All right, so let's get started. So this is where we're kind of been focusing on. So let's just kind of review it once more, and then we're gonna hopefully get to do all the phases. So we started talking about, so we have the proposed phase. So first of all, the client send the message to the primary. Primary take that client request and propose it to all replica. Then we have a exchange of messages, which is our prepare phase. And then we do another, and so once we get enough prepared message, once we're able to form that quorum, then we enter the prepared state. Then we do another exchange of messages, and once we are able to construct the commit quorum, and this is individual, so R3 or R2, each individually construct that commit quorum, meaning 2F plus 1. Once they're able to construct that, then we get into the committed state. And once you reach committed state, then you inform the client. And then once the client also collect enough messages, then the client consider the transaction to be committed. So this was sort of the flow. Now let's kind of go back. Let's stop here for a moment again, once more. So who wants to start us off? What do we gain in the prepare phase? The majority of the replica receiving the which same message? Which same message? Yeah, what is the message they're receiving that they're supposed to be the same? Message from? So at the end of this, for example, R4 can say the majority have received, or it seems the majority have received the same message from the primary. There's another thing. Okay. All right. So at this point, R4 knows that the primary didn't lie, or at least didn't lie to the extent that was detectable. I mean, it could have lied, but maybe only lied to a small portion. But as long as I can form a prepare certificate, meaning I can form the majority that's saying that they've received the same message as I have, for example, from the primary, then I get to the prepare state, and then I can conclude that the primary didn't lie. Or at least if it did lie, it wasn't significant. Because, for example, can I guarantee that I always get the exact same message, even if the primary didn't lie? Why not? Let's assume there's no network problem. If there's no network problem, and if the primary didn't lie, can I ensure that I get 3F plus 1 identical messages? Why not? Mm-hmm. Okay, because there are F people who just lie. Even though the primary tell them the correct message, they say something else. Or they don't even send a message. So the best I can do is that 2F plus 1 saying that the primary has given them the same message. And so I know at this point that enough people got the same thing. So I get to the prepare state. So now, why is it this is not sufficient? Why do I need yet another phase? Why can't I just, because I already know enough people got the same message. I already know, R4 already knows that the primary didn't lie. So why is it that we need yet another set of exchange of messages. If R4 already knows that the primary didn't lie, why can't just R4 go ahead and inform the client?
Even though he message in case of if the primary lies.
But we already established primary didn't lie. So at this point, we said the primary didn't lie. So how else could the primary lie? So give me an example.
Let's say there are including primary 10 replicas. So
Say in terms of F.
so 3F plus 1 replicas
Mhm.
with primary it's rest of 2F plus 1 is our replicas.
Okay.
And in this case, the primary, which is 40 replica,
Mm-hmm.
send to F plus 1 message.
Okay. Let's try. So we have how do you want to construct the core? So we said we need this one to be 12 plus 1. And we have, as we said before, we have F good replica. We have another F good replica. We have F bad replica, and then we have another one good. So we have 2F plus 1 good replica, and then we have F replica. So how do you want to distribute messages? So what is the primary is doing? So what is it that we could say, again, as we did before, we could say, we put a superscript of the message. What do you want the primary to be sending each of these?
So I will say primary sends the 1, let's say, message 1 0.
So we have message A and B, let's say, or 1 and 0, sure, 1 and 0 is fine. So we have message, you have a message 0 and a message 1, or a request 0, and so these are the two messages. So how do you want to distribute it?
I want to send the message 0 to the 1 and F.
To F plus 1?
To F plus 1.
So you want to send the message 0, for example, to here and to this one?
Yes.
Okay, so and what is
sending the M1 to.
Okay, so you get 1, let's just call it 1.
And for the bodies, it stays 0.
It doesn't really matter. I mean, you could give them whatever you want. Okay. All right, so now you have F plus 1 good replica who got 0, and you want to put the bad one in there too. Okay, so you put the bad one in there. Okay, so do you have a core?
Yes.
Okay, so you have a prepared core. For whom? Let's say R4. R4 is a prepared core. Okay, so then what? Now what?
Now, if we assume the commit traces like remove and we are able to the inform, and let's say if the M1 is the correct message, but M0 is not.
Say that again, M1.
If the M1 is
They're both valid. You cannot send an invalid message. Both M0 and M1 has to be valid.
yeah, they both valid message, but there's one message like that's not supposed to be sent at that time.
Again, does anything can happen with M1? This is very important. This is a very important property. The moment you form a core, that core is going to be unique. That means it is impossible to form another core with a conflicting message. A prepared core, it gives us uniqueness. Meaning, once you form a core of something, and again, we do consensus in round. Once you form a core for message 0, let's say in round 1, it is impossible to form any other core. We can try to see if we can construct an alternative one. But is it possible that I do anything? Because if I now form a core, so this is for message 0. So I've already formed a core for message 0. is it ever possible to construct an alternative form? Because in order to construct the alternative form, what could happen? Well, we have F good replica, who's gonna say 1. We have F bad replica, who previously said 0, but they may very well say 1 again. How many do we have? Who have? So we're missing 1. The only one that could potentially help to construct is one of these good ones. And if they've already voted for 1, I mean, if already voted for 0, they will never vote for 1. So this core is never going to be created. So once we agree, once we prepare 0, it's guaranteed to be unique. It may not survive, that's a different question. It might not be preserved, that's a different question. But once a quorum is formed, it's unique. So, what do you want? Do you still have anything else you want to visual example to see what you can construct? Okay, so what is it that we're missing? What is it that we're missing at this point? We know at least that we can talk about the perspective of R4. R4 has reached the prepare quorum for message 0. And so R4 knows that the primary didn't lie. So in fact, primary didn't lie, or at least the primary, again, we will conclude the primary didn't lie here, even though it had gave wrong messages to someone. But it did sufficiently well. So there was a sufficiently well behavior because we were able to form a quorum. So we know that the primary, we can just say primary didn't lie. Or lied up to a threshold that was undetectable, or lied up to a threshold that didn't matter. So why do we need to continue? Does this make sense? Any question on this part? Is the uniqueness property clear? Yes. Okay, so why do we need to continue? What's missing? Yes.
So for those conclusions that you just established, their own R4. Yes, R4 knows the primary did not lie. Yes, R4 knows that that form it was sent to the other replicant. However, what if there was network failures between like during the prepared state and let's say R2 or R3 did not receive 12+1 messages from all the other nodes. So what R4 is that this is the majority, this is what the majority of the node received from the primary, therefore primary is not faulty, but other this node that's what R3 or R2 R1.
Okay. All right, so let's do this example. I'm the primary, okay? And I'm going to propose a message to all of you. I'm going to propose 0 to everyone. Okay? What are you going to do? You're going to do prepare, meaning you all got to exchange messages. You're going to all say that you got message 0 from me. Yes? So now you got 12+1 messages. So why don't you stand up for a moment? So he got 12+1 messages. Okay? He's the only one standing. He's standing because he can attest that I didn't lie. Everybody else so far is sitting down. So is it okay for him to just tell the client, we're done, or not? Why not? He already knows that I didn't lie because he already got messages from all of you that I sent message 0 and he's standing. Could he just tell the client and be done with it? What could have happened? No, which one?
Client still is 2+1.
No, client is F+1 actually. Well, I mean, in this protocol, client is F+1. And why is it the client is F+1? Is because if client could, F people could lie, so then it's essentially discarded. But if there's F+1 tell the client, then it's good because at least he knows there's one person like him who didn't lie, and he's saying that the primary didn't lie. So client can count on that. But why is it that that's not sufficient? There's one person standing right now that knows that the primary didn't lie. And so far, he's the only one who knows that. So what could go wrong if we go ahead and tell the client we're done?
But the good is not up to date yet.
Who's not up to date? Who's the most up to date one? Is standing. But this is from all of you.
Yeah, like the previous, like.
There's no previous. There's only one ground, one transaction. Forget about previous.
The other replicas I have received like 2 plus 1 messages.
So, for example, you haven't stand up because you haven't got enough messages. So you don't know yet that whether I'm right or not. So what's the problem?
So this when I believe there's no point.
Why not?
Because we don't actually have
Well, maybe they could in future. What's the problem? What could go wrong? You know that I didn't lie. I mean, he knows at least I didn't lie. Why couldn't he just finish it? Huh? Can what? No, he's not lying. He's an honest man. Assume he's not lying. Why would I create a fork? But could you go back to this? Could you ever come up with any alternative? If he got M0 and is standing, a quorum was formed, could we ever get M1? Because that's what I was established. This is a uniqueness. Once a quorum is formed, no alternative quorum can be formed for that round. And let's stay with just one round. We're not going to go beyond one round. So it's more than that. The moment he established I'm not lying, he also established that no, this is a unique. I mean, nothing else can be accepted. It's unique. So what could go wrong? Unique means there's only one. If a quorum of M0 is formed, we cannot possibly form another quorum as we tried to do for quorum 1.
So if one replica reached, we can compare with message one, the possible for another replica gets
A different quorum. It's impossible. Because we tried. The worst we could do is to keep F people in dark, give them something else, and have F people could change their vote. And so we could get up to 12 points, but we were missing one. And that one has to be from one of these good sets. And if they've already voted for 0, they're not going to vote for something else. So that's unique. So that's important. Not only that I didn't lie, it's also unique. He knows that that's unique. No alternative can be formed. So what could go wrong? Why do we need another phase? What if we all don't get anything? So he got it, is good, tells the client, but among us, none of us get anything. And then what we decide to do, we decide to do a recovery, we decide to change the leader, and we ask, did we prepare anything? Or did we commit anything in the previous round? And that's we have to see because we want to preserve whatever was committed. At the moment we ask that question, did we ever prepare something? It's possible he becomes unreachable. He gets partitioned out. So he's no longer accessible to us. And if we now survey among ourselves, say, did we ever commit anything or prepared anything in the last round? What would be the answer? No, because we missed them. Are we going to form a quorum among ourselves? Are we going to form a quorum? Are we going to have 2 + 1? Because there's only one person. There's more than majority is still around. If you ask the majority says he didn't do anything, didn't get anything. So if he would have done it by himself and there was a recovery happening, then we would miss it. So why? What happened then? Because he was the only one who got locked on a message. He was the only one who knew that the primary didn't lie. And just having one person to know that the primary didn't lie, only having one person who committed or having one person who prepared, it wouldn't be sufficient. Because if the recovery goes, we just need a quorum, and a quorum is only 12 plus 1, and there's enough of us that could have 12 plus 1 to come up with an alternative decision. So how do we have to ensure that if I were to construct a recovery core, at least one of the people who were standing is going to be that core? What do I have to ensure? Yes.
I think I have a question. Because we said that our core right now is the only person that knows that core must read, correct?
This is question gonna last a long time. So you're gonna be prepared for standing for a long time. Go on.
Why does R3, R2, and R1 not also they should have the same information?
Why would they? Why they should? We just did the example. The all exchange messages is the only one who got it. The rest are lost. All the other messages were lost. You didn't get it. You're still sitting. So it's a distributed system. Just the fact that he got it doesn't mean you got it. Maybe the messages are lost.
So everyone's messages got.
Everybody's message is lost. You can make arbitrary choices because the network could be adversarial and you could make adversarial decisions to drop things. There's no guarantee that he got it, then you got it. First of all, you don't even know whether you got it or not. You know whether you got it? The only thing you know whether you got messages or not.
Okay.
That's the only thing that you can know. As in general, anything you know is something that you know, something you've experienced. Think about that. That's a lot of that implication. Say that again. Okay, if you have F plus 1 standing, how many of them could be lying? When I could just stand, you could just stand without having gotten any messages. How many of them could be lying out of that F plus 1? Okay, so F of them are lying, and then we're back to the same thing. You ask what happened, F are lying, they're gonna change their vote, and you can exclude them. How many people need to be standing?
Sorry, so it will be 2 F plus 1, so in case of recovery, majority of us can come to the board on that A data message, we did all receive it, we did have a board. And yes, we were all standing.
So if enough people standing, that means 2 F plus 1, F of them could be lying, so that means they will say later on changing the vote. We could keep out up to F, but we still have to keep 1. As we said, any two core out of the 2F plus 1. So let's say these are okay, put it this way. We construct a core, there were let's say F people who were in let me do this way. I want to make that simpler. So if we have a prepared core, that means we could have, again, it's actually end up to be the exact same example. So we could have a prepared core, F plus 1 are good. We have 1 good here, and we have F bad here. Actually, this should be G. We have F bad here who says good, who says also 0. And then we have F good guy who are in dark, who never saw anything. So that's a possible core. And that's the worst possible core. We have F plus 1 good one, B bad, and then we kept G in another F good replica in dark. So they don't know what happened. They haven't seen anything. So now if I were to form a recovery core, I need 2F plus 1. And in my recovery quorum, these guys could participate now. So we have G people who says nothing happened, let's say. Because they didn't see anything. They're gonna say nothing happened. There are F bad people who did participate. Now they're gonna say also nothing happened. So now we have two F people who says nothing happened. We need one more. Who is it gonna be? Either this or this. And one of them say, wait a minute, something did happen. And so that thing will be written.
It's like, how do you raise not the one people that got it? Only one.
Because at most we keep F in dark. At most F can change their vote. That gives us with 2F. So F people were in dark, F people changed their vote, but we're missing one from forming a core. And that one who's gonna join in order for help us to form a core is one of the good guys. And the good guy, we say 0 was prepared.
But I guess it's like, I guess of course, like, how do you know that like each one is correct? Like which one should we go to? Should we go to like nothing as a number?
Say that again.
So like each one we have like two people said nothing and zero said 0, right? How do we know that was correct? Or
So that's a good question. Let's say somehow this, it can show a proof. That one good one can show a proof. The other one cannot show a proof. Because a proof means a formation of a prepared certificate. Proof means a formation of a prepared certificate. And if let's say all of these messages were signed, they're digitally signed, this person have gathered 2F+1 digitally signed message that can be later forwarded, and that becomes the proof and certificate of the prepared core. So when this happens, this is the only one who can actually prove, show a certificate, show a proof that in fact something prepared. These ones don't have a proof. This one, because there was no other quorum was formed, was this going back to the uniqueness. Only a single quorum was formed, and that one can show a proof. The other one can't because we didn't have a quorum of 1 for message 1. The only quorum that was formed is 0. And we also said once a quorum formed is unique. So that one has a proof. The other one don't have it. So that with that proof, we can ensure that that 0 is preserved.
like the register with the is correct.
Yeah, because it's a proof. The whole point of a proof is that means it's provable. It's a certificate. Yes.
So basically, once you have a core, then that means the message is.
Once you have a
Once you have a core form, what's going, that means you.
that means you know that at this stage, you know that I didn't lie. But if you stop here, you may be the only one who knew about it. The rest don't know. So the moment you add this phase, so whoever reaches that state, knowing that the primary didn't lie, becomes locked, becomes prepared, and at that point, stand up, meaning tell everybody I didn't lie. And if enough people say primary didn't lie, so if enough of you end up standing, that's the formation of commit core. And now, if enough people observed that the primary didn't lie, that means now if recovery happens, even if some of them are no longer reachable, at least one of them will be reachable. At least one of them will be reachable, and that one will have a proof. And so that will be preserved. So I'll get to your question. So what this one does, it sends out what the primary had proposed. What this phase does, it says primary didn't lie. And at this point, I know enough people know that the primary didn't lie. At this point, the only thing I knew was that I myself reached the conclusion that the primary didn't lie. But at this point, I now reach a conclusion that the majority knows that the primary didn't lie. At this point, I reach a conclusion that the primary didn't lie and I'm locked, but I don't know what the state of the other is. But at this point, I now observe that the majority are also locked, meaning the majority also knows that the primary didn't lie. And so if this phase ensures the uniqueness of this core, this phase ensures the preservation of it. It ensures the preservation of it because it's been replicated by enough people. There's enough replication. He knows that I didn't lie. He knows, there's enough people know that I didn't lie. So even if the recovery happens, one of these people will finally stand and make sure that that transaction is preserved. Prepare gives you uniqueness, commit gives you preservation guarantee. The unique gives, this one gives you that the primary didn't lie, and also a quorum that is formed is unique. This one gives you a preservation, meaning enough people now aware that the primary didn't lie so that it's okay to inform the client. 12+1. Enough means that you can ensure there is an overlap in a port. And the overlap of a port is that as long as the quorum size is 12+1, it is guaranteed that they will be intersecting on one honest replica. And that one honest replica ensures no divergence. So how many replica do we need at this stage to inform the client? Why 12+1? Why does it have to be quorum? Doesn't mean always have to be 12. I mean, sure, quorum and I mean at least needs to be 51%. But why do we need 12+1? Why not F+1? Why not just 1? What was the argument? The argument was what? We need to make sure that what? How many people are locked? How do we ensure that 12+1 are locked? No. So is it sufficient if a single replica gets to the committed state, a single honest replica gets to the commit state? How many replicas are locked? If a single honest replica, if R4 gets to the state, how many replicas are locked? 12+1 because they send a commit message. So would be just sufficient one message, one honest replica to tell the client? One honest replica. Which means what? What does one honest replica translates to? F+1. Because as long as you have one honest replica, or if the client is counting, has to count at least F+1. As long as one honest replica reaches the commit state, means what? Enough people were locked, enough people are prepared, their 2F+1 are prepared. Out of that 2F+1, F of them could be lying. Out of that F+1, F of them could get disconnected, but there's one of them will remain if you ask or if you try to construct a recovery core. So as long as one honest replica reaches this state, then we can ensure preservation. Question. They could all send a message to the client, but the question is, when I reached that stage, it was premature to tell the client. But if I arrive here, even though I don't know whether if anybody else is committed or not, when R4 committed, does it know whether R2, R1, and R3 are committed or not? So is it safe to send it to client unilaterally? Why?
So we know that it's correct.
Okay. Okay, but how come the same argument as before doesn't hold here? That we say, if you only the one who reached at the prepared state, you cannot unilaterally tell the client. How is it that here I can now unilaterally tell the client without knowing if everybody else are prepared, are committed?
Say, we know majority of the, everyone size received and agrees to commit.
See to commit? How do you know that? Commitment, once you get to this state, you're committed. You were not committed if you were prepared.
Correct.
So once you're prepared, you send a message, but committed is at this point.
Well, not people that think that the principal sender, right, has sent the accurate message and. So
Well, we established that here. Talking about this, the validity of this message, this was established here.
But only I do that, when the R4 and at the end of the days, R4 now knows that already the majority of R1, R2 have been R4.
Knows that they're what? In what state there are. At this state, what can I conclude about the state of everyone else? What is their state? I mean, what is the majority state of the majority? At this point, what can I assess about the state of the majority? In what state they are? Prepared, they're locked. And since I know the majority are locked, I think locked is a better name than prepared. Prepared is, I don't know, it doesn't mean much. If enough people are locked, then I know that when the recovery happens, at least one of those people who are locked, they're not gonna let go. It said, wait a minute, I'm locked on this, you can't change it. You're gonna preserve it. I'm gonna talk about it. So recovery means basically what recovery is, we can't make progress, we stall, and then we have to ask, or we have to kind of try to recover ourselves. And the way we recover ourselves, the first thing we do, we say, what was done before? Or the first thing we do first, this was our current leader, then we have to decide who the next leader is. And the first task of the new leader is to ensure the preservation of everything that was committed or could have been committed. Anything that we could have told the client, you're done, we want to make sure is preserved. Any promise is made, we want to make sure commitment is a promise. You commit to something, you promise. So whatever commitment was made, we want to be able to preserve, or more accurately, whatever that was committable, we want to be able to preserve. Yes.
If the client receives a +1 message with only one on this replica, how can the client confirm that which message is the correct one?
Is if they're matching. It has to receive a F+1 matching messages, meaning that F+1 tells you, if you're the client, if F+1 tells you your message is committed, your transaction is committed, your request is committed, then you know one of them is telling you the truth, so that means your request is committed. So you can be sure that transaction will be preserved.
So how could I know that which one is?
But it doesn't matter which one, as long as you know one of them. You only know one of them because they're all saying the same thing. F+1, because F of them could be say arbitrary thing, but if one of them is telling the truth. So if there are F+1 matching one, that means one is telling the truth. So the whole map, so that argument sort of holds. So what they're saying, even though you don't know which one is telling you the truth, but their overall message is reliable, because one in that set tell the truth, and so that means what is being conveyed is truth, for the lack of better word. Say that again? Yes, and we don't know, maybe they're all lying.
Something like if the one saying different from twice, like do some verification.
No, unless they can show a proof that that commitment was reached. The same argument that I used for that one person showing a prepare proof, we could potentially show a commitment proof. And if we're able to show a commitment proof, then that's the proof. Right now, since we're not showing a commitment proof, then we need F+1. Gathering F+1 same messages is the proof. Or individually, they could have sent the proof. And the reason we typically don't send the proof in here is because the complexity of the proof is n. And if everybody, because you don't know who's going to send it, so we end up telling everybody to send it, and the complexity of the communication becomes n squared. But versus if everybody just tell the client your message was accepted, we know that at least some of them will be honest, and so we could reduce the informed complexity to linear. Otherwise, it would have been quadratic. But essentially, the client needs a proof. Either you send it a set of signature that's showing that commitment was reached, or F+1 tell the client that was committed. And if F+1 says it was committed, you know that one of them is telling the truth, and that's sufficient. Questions? Ready for the quiz? Yes.
Know that there are truth plus one replica, or does it know that truth plus one replica? That's the same message.
Yeah, it all has to be the same message. If they're not the same message, we're not even going to get to the prepare state. Prepare state already says that they are same messages, the same request. If you don't, if you didn't construct the core of the same message, you don't get to prepare. Yeah, it's simple. That goes back to the uniqueness property. What's up? Sure, you can draw, as long as your drawing is good. You can erase whatever you want to or change.
This picture.
Sure.
I think that if the better replica, they may tell this F that it gets 0 and
Yeah, so draw it. What up? So put it here. These F tells 0 here and tells
one here.
Yeah. So what happens?
So it's like this.
So maybe just separate it. So draw 2. Let me do it. So there you go. So you have F bad ones, which tell you 0.
Yeah.
You have F bad ones to tell you 1. You have an F good one, got 1.
Yeah.
So this is what? 2F. This is also 2F. And then you have one more good replica. Where do you want to put it?
Oh.
Whichever you put it, the other one not going to have a core.
Oh, that's
Got
it. Got it.
Okay. Any other questions? Well, think about it. We can continue on this on Wednesday, and then we're going to slowly go to the view change and recovery. But we're going to kind of spend a little bit more time on this, make sure everybody's on the same page.